Okay, in this next step we're going to calculate the aspect for our DEM. Aspect is the direction that the slope is facing, so it helps us identify things like northern or southern exposure. We are interested in determining how much of this watershed faces east, and so that's going to include northeast and southeast. So I've already run it here. You're going to go and search for the aspect tool, and again you're going to want to bring up the spatial analyst version. Put in your Ogden LiDAR again, and then I would just name it Ogden Aspect. When it is done running, it should run really fast. It outputs like this. Okay, so this is the typical aspect output, where we have flat cells with a -1 cell value, and then you can see that they're just the cardinal directions from 0 to 360 classified into the different directions. So because we're interested in east facing, we're going to be interested in a class that's defined by the numeric values 22.5 through 157.5. That's going to incorporate northeast facing cells, east facing cells, and southeast facing cells. So we want these three to be combined into one class that's kind of a true, and then the rest of them will be combined into a class that will represent false, and we're going to actually assign those away to no data so that they go away. If you remember with the slope analysis and the raster calculator, we ended up with a binary output of 0 and 1, where the zeros represented the falses and the ones represented the trues. But then in the output, we still have two classes. In this instance, we're going to write away the falses, and we're going to get rid of them altogether. So we're going to use the Reclassify tool. We're going to input our aspect raster, and then you can see here all the different classes that are represented. They're auto-filled here. We're going to use the Classify shortcut, and we're going to put 3 classes in, and this is just trial and error. But we want to recreate those same classes that we were just talking about. So we want 22.5 to define the lower bound, and 157.5 to represent our upper bound, and then we're going to leave the maximum value in there. You can see it redraws our classes for us and simplifies things. And because we want to preserve this eastern class, we're going to let that one equal 1. So this is our old value, and then this is the reclassified value. And instead of preserving these other classes, we're going to actually change them to no data like this one is. And this is case and space sensitive. It has to be just like that. So no data and no data. You can just literally write right over them. Set our output. I'm going to call it Ogden Aspect Reclass. Something like that. Hit save and okay. And when it's done, it looks pretty funky, but we're still displaying the original aspect behind it. So you can see that we've assigned all of these non-eastern facing cell values away to no data, and that's why we can see through it now. If we take that away, it's just our aspect reclass with our true values, if that makes sense. And so because we're interested in the total area again, we can look in the attribute table, and we only have a true value now, and this is the count. But again, that's for the entire DEM, and we're only interested in the watershed. So we need to extract by mask again. Just so you know, you can also run a clip. Just make sure you run the clip that comes in the data management toolbox. Those work on rasters. I think this tool just simply works better. So we want to take our reclass, our mask is our watershed, and see if it'll take that unit. It's limited by 13 characters. If you click on that, it tells you that the output name is too long. So I might just get rid of the reclass bit. Okay, doesn't look that much different, but you can see there's a whole new color now. If we turn off the input, Now we're just dealing with the eastern facing cells in our watershed. If we look in the attribute table, it should be a smaller number, and it is. So again, we're going to multiply this count, this is the number of cells facing east, by the area of one cell, you guys have done this before, to get our total area that faces east in this watershed.